Your fitness tracker may be recording something more interesting than your step count. A new study suggests that the pattern of your movement across an entire day may contain clues about how quickly your body is biologically aging. Researchers followed more than 2,200 people using years of Fitbit data and compared their daily activity rhythms with a blood-based measure of biological age. People with stronger daily activity rhythms had 26 to 46% lower odds of accelerated biological aging. And the surprising part was that the signal was not simply more steps are better. Timing, regularity, and the shape of activity across the day also mattered. The Nature Communications study, published on August 23, 2026, used data from the U.S. All of Us research program. The 2,222 participants had a median age of about 61, and roughly 69% were women. Together, they contributed 8,447 person-years of Fitbit recordings. Instead of giving everyone a wearable for 1 week and taking a snapshot, the researchers analyzed activity repeatedly over multiple years. That allowed them to ask a more useful question. When a person's daily rhythm changes, does their biological aging trajectory change with it? That distinction matters because most fitness advice reduces movement to totals: 10,000 steps, 30 minutes of exercise, 5 workouts per week. Those numbers can be useful, but two people can achieve exactly the same number of steps while living very different biological days. One person gets out of bed at a regular time, becomes progressively active through the morning, reaches a clear daytime peak, slows down in the evening, and repeats that pattern almost every day. Another accumulates the same total activity through irregular bursts scattered between long sedentary periods, with activity drifting later into the night. The Fitbit sees the same total steps. The body's circadian system may not. Researchers therefore examined what is known as the rest-activity rhythm, the approximately 24-hour pattern created by alternating periods of movement and rest. This rhythm is influenced by sleep, exercise, work schedules, light exposure, meal timing, and the body's internal circadian clock. The study measured several properties of that rhythm, including its intensity, how clearly daytime activity differed from nighttime rest, when activity peaked, and how regular the pattern remained over time. Then they compared those signals with phenoage. Phenoage is not a number produced by the Fitbit. It is a biological aging measure derived from clinical biomarkers combined with chronological age. If someone's physiology resembles that typically seen in an older person, their biological age estimate can run ahead of their calendar age. The researchers could therefore compare changes in real-world behavior with changes in a completely different biological measurement obtained from health data. Depending on the metric, the reduction was about 26 to 46%. For example, increases in one measure representing the most active 10 hours of the day were associated with about 46% lower odds, while stronger overall rhythm amplitude and activity level also showed substantial associations. That does not mean a 46% reduction in your chance of dying, nor does it mean a Fitbit can tell you that exercise has made you biologically 10 years younger. These were odds of being classified on an accelerated biological aging trajectory. The study was also observational. Researchers found that activity rhythms and biological aging changed together over time, but they did not randomly assign people to different schedules. So the results cannot prove that changing your daily activity rhythm will directly slow aging. Still, the longitudinal design makes the finding more interesting than a simple comparison between active and inactive people. Previous wearable studies have often collected only about a week of movement data. A week can tell you what somebody did recently, but aging unfolds over years. Here, repeated measurements allowed researchers to look at trajectories. When activity rhythm became stronger or weaker, they could examine whether biological age measures tended to move in the same direction over time. Then came the second important result: regularity. People whose daily activity patterns were more consistent tended to have lower odds of accelerated aging, although this association was smaller than the effect seen for rhythm intensity. Depending on the analysis, greater regularity was associated with roughly 9 to 13% lower odds. The researchers also found that later timing of the daily activity peak was associated with about 22% higher odds of accelerated aging. This does not mean everyone needs to exercise at 6 in the morning. The study did not identify a universal ideal workout time. and a late activity peak could reflect many things. Late work schedules, delayed sleep, health problems, lifestyle patterns, or individual chronotype. What it does suggest is that the timing of movement contains biological information that disappears when researchers look only at total steps. Imagine two graphs covering 24 hours. A healthier-looking rhythm might resemble a strong wave. Low activity during sleep, a clear rise after waking, sustained activity through the day, and a decline toward evening. A disrupted rhythm might look flatter or more chaotic, with weaker distinction between active and resting periods. The first person does not necessarily spend every hour exercising. Their day simply has a stronger contrast between activity and recovery. Why might that matter for aging? The body operates on clocks. The brain's central circadian pacemaker coordinates daily cycles and hormones, metabolism, body temperature, immune activity, sleep, and many other physiological systems. Peripheral clocks also operate inside tissues. Movement itself provides information to these systems. Regular activity during the biological day can reinforce the difference between daytime function and nighttime recovery, while highly irregular schedules can blur those signals. But the relationship probably works in both directions. A person who is biologically aging faster may become weaker, sleep worse, develop chronic disease, or move less consistently. In other words, disrupted activity rhythms might contribute to poorer health. But poorer health can also disrupt activity rhythms. That is why the researchers describe these wearable patterns primarily as potential digital biomarkers rather than proof of a treatment. The sex differences made the story even more complicated. Stronger rhythm intensity was associated with better aging trajectories in both men and women, but timing and regularity showed stronger associations in women. In women, delayed or less regular activity patterns were more strongly linked with accelerated biological aging. In men, researchers instead identified what they described as a biphasic instability pattern, involving unusually high early morning activity, followed by another rebound later in the evening. That does not yet tell us why men and women differed. Hormonal biology, work schedules, sleep patterns, disease burden, activity behavior, and other variables could contribute. It does, however, argue against turning the study into one universal prescription, such as exercise at exactly this time to slow aging. The useful signal may depend partly on the person. There is another reason the findings are interesting. Measuring biological aging normally requires something from a clinic: blood, imaging, DNA methylation, proteins, or other biomarkers. A wearable is different. It passively collects thousands of measurements while a person is living normally. If those data can eventually identify a deteriorating aging trajectory before obvious disease appears, a device already sitting on millions of wrists could become a remarkably scalable screening tool. This idea is already becoming more plausible. Other research using all of us Fitbit data has shown that longer wearable monitoring windows tend to produce stronger and more stable associations with disease than single-day or one-week measurements. One study analyzing 11 million days of Fitbit recordings found that year-long measures were associated with substantially more health outcomes than very short measurement windows. The lesson is simple. One unusual day tells you little, but the pattern of thousands of ordinary days may reveal something important. But consumer wearables have limitations. Fitbit measurements are not perfect clinical instruments. Step estimates and physical activity intensity can vary depending on movement type, device behavior, and measurement conditions. Wearable users are also not a random sample of the population. In the All of Us Fitbit cohort, women and non-Hispanic white participants have historically been overrepresented, which can affect how broadly findings generalize. And there is a more fundamental problem. Even phenoage is a biomarker, not aging itself. A better phenoage trajectory does not automatically mean someone will live longer. Biological age measurements can summarize meaningful physiological risk, but longevity ultimately has to be demonstrated through outcomes such as disease, disability, health span, and mortality. So this study does not give us a new anti-aging hack. It gives us a new way to look at something extremely ordinary. Instead of asking only how many steps you took today, imagine asking whether your body still knows when daytime begins, when activity should peak, and when recovery should start. Is there a strong difference between your active day and your quiet night? Does that pattern remain reasonably stable from week to week, or is every day completely different? Those questions may eventually matter because aging is not only a process happening inside DNA or mitochondria, it also appears in behavior. Someone becoming frailer may move more slowly. Someone developing sleep problems may become active at unusual hours. Metabolic disease can alter energy and sleep. Depression can flatten daily activity. A wearable may therefore capture the outward pattern created by many internal systems at once. That may be why the strongest signal in this study was not a single workout. It was rhythm. A strong day followed by a clear night. Activity that rises and falls rather than remaining flat. Enough regularity for the body's systems to anticipate what comes next. We still do not know whether deliberately strengthening that pattern will slow biological aging. A randomized intervention would be needed to test that. Researchers would have to change people's activity timing or regularity, then show that biological age trajectories and eventually meaningful health outcomes improve. But if that happens, the future biological age test may look very different from the expensive tests being marketed today. You might not need to send a sample of your DNA anywhere. Your body may already be revealing part of the answer through the pattern of how you move every single day. And your watch may already be recording it.